In the above problem, what is the value of Darcy friction factor using the Colobriggs-White equation? If the modified Colobriggs-White equation is used, what is the difference in friction factor? Calculate the pressure drop due to friction. In a 5 miles segment of this pipeline using a pipe roughness value of 0.002 inches. Now, this is a problem above, this is a problem. So we have gotten the internal diameter. The internal diameter D is equal to 19.25 inches. Now, they have given us the roughness, the pipe roughness as 0.002 inches. They say calculate what is the value of the Darcy friction factor using Colobriggs-White equation. And the Colobriggs-White equation is 1 all over the square root of F equal to minus 2 log base 10 E all over 3.7D plus 2.51 divided by Reynold number square root of F. So this is Colobriggs-White equation. So, but the modified Colobriggs-White equation is this: 1 all over square root of F equal to minus 2 log 10 E divided by 3.7D plus, this is 2.825 divided by Reynold number square root of F. So this is the modified. This is a modified Colobriggs-White equation. Then this is the Colobriggs. So this is the Colobriggs-White equation. Wow. So this unit is the same unit, so it will cancel out. This will cancel out. This is inches, this is in inches, it will cancel out. These ones are dimensionless, so these are dimensionless, so it will work out well. Now, what we're going to do, we're going to use go seek in Excel. We're going to use Excel. So, and we have calculated our Reynold number, which is this. Now let's open Excel. I will type, let's say, internal diameter. Internal diameter. Okay, we put in internal diameter, and then this one is roughness, pipe roughness. Pipe roughness. This internal diameter is 19.25 inches. Then this is 0.002 inches. Now we have the Reynold number. The Reynolds number what we got was 203114. This one is dimensionless, so now we needed to name this using name manager. Go to formula name manager. Now add a new name. You say the name should be D. Let me say small d. I will select say equal to this one. It's okay. So this that. Then let's add another new name. Call this one. I use E. So equal to this. Say okay. Now I add a new name. This one should be what is the name? Let me say equal to this. Now we're giving that one a name. Now so we'll close. We needed and assumed. So let me see down here. Let me just format this. Guys, use a format page to format that row 8. 3 columns on row 8. So I will say these are calculations. Calculations again. Let me make all capital letter. Calculation. Yes. Now this. Let's say. Let me use an assumed friction factor. Assumed friction factor there. Now let me assume a friction factor of 0.0008. Okay. This is 0.0082. Now I'll calculate for Colobricks. I'll use Colobricks equation. Let me see. Let me call this Colobricks. Colobricks equation. Now let's call this one modified Colobricks. Now this should be equal to, going by this, I'll move the whole of this to this side, so it will not be, so the equation I will use there now, this one now will be this. Let me call this equation, Okay, I'm starting. This is a new problem. I'll just call this equation. Okay, let me say this is 5 4. This is equation 6. So let's call this equation 7. And call this equation 8. So let me just say rearranging equation 7. I will have 1 all over the square root of f plus 2 log 10 e 3.7d e divided by 3.7d plus 2.51 divided by Reynolds number square root of f bracket open and close is equal to 0. So this should be equation 9. Now let's rearrange. So let's rearrange equation 8. So we now have 1 all over the square root of f plus 2 log base 10 e divided by 3.7d plus 2.51 divided by square root bracket open divided by Reynolds number times square root of friction factor equal to 0. No, this should be 825. This should be 825. Let me see. 825. 2.825. This equation 10. So using this now, let's go back to Excel. So this should be equal to 1 divided by the square root of, okay, let me, before I proceed, let me name this. Let me name this B9. Okay, correct, B9. Let me name it, let me say F. Okay, it's correct. It has a name here. So I'll come here, I'll just say equal to 1 all over the square root of f bracket close plus 2 times log is 10 bracket open E. See, as I said, E, the thing has highlighted the pipe roughness. So divide by bracket open and close, bracket open and close. You have 3.7 times D say plus 2.51 divided by bracket open and close. In here is a Reynold number times square root of f square root of f bracket close. And then close the bracket again, which is the whole of this. So now you enter, so you have that. So the whole of this is the same thing. So what I will do, I will drag it down. I'll just select this and change this one to 825. Now we have, these are the difference here. So let me highlight this. Let me select that and use it to format these cells. Now we will now say our okay, let's say view. Let me remove the grid. Let me select here as our result. Let me just select this place, use it to format these three cells. Then here should be the result. Let me make all capital result. Now the result should be the difference, because that is what they wanted us to calculate, the difference. The difference between this and this. So we'll just say this equal to, let me say this minus this. So now for us to get the exact, okay, no, this should not be this minus this. So now this minus this. So there is a little error here. Now I needed to insert another form here. Now let me say this is for I'll say this is for Colobrook's equation. Then this one, the next one here should be for, let me copy paste it. This should be for the modify. No, this should be for modify. So change this to 0. This one should be for modify. So the difference here now will be equal to this minus this. So now let me say assumed, say modified assumed modified friction factor. So this is it for this one, for this. So what I will do now is to edit my values. So now here I need to change. Okay, I can leave this one like this. Then this other one, I edit it. I will just call it F underscore 1. Enter. So no close. Then I'll come here and change it. I'll change this to F. This is F underscore. Is this? Where is it again? Here again. Change it to F underscore. Yes. So we'll have this. So let's calculate for color breaks first. I will now go to data. This go seek. Now set a cell. Now I'm setting this cell here. This one in particular to value 0. This should be 0 because when you look at the equation, we rearrange this and make this plus this equal to 0. So we needed to set it the value of this to 0. Now by changing this, I will say okay. So we'll have let me make it to 4 decimal place. Okay, let me leave it like this. Let me leave it this way. Then this other one, we also use go seek. Go look. Okay. What if analysis? Select go seek. Now we are looking at this, but this is a modified color-based equation. Now we need this to be 0, just like what is here. This is it. This is a modified color-based equation. So we have rearranged it and make this plus this is equal to 0. We rearrange it. So now this, so the equation here we put here should be 0. By changing this one, by changing the modified. So we'll click OK. So now we have this. So this one gives us, let's adjust these two things. This one should give us let's make it to 4 decimal place. This is it. So this is the answer. This is the difference. It's in the two. So that is it. So we are done. So we have assumed friction factor is this. The assumed friction factor is this. Now this is not the assumed friction factor. Now this is real friction factor. This is the result. The real result. Now I will make this equation equal to 0. And this one for modified friction factor, this is what will also make this equal to 0. So, and the difference is this, because that is what they want us to calculate. They want us to calculate the difference. It's a calculate. Okay, what is the difference? Okay, in friction factors. So calculate the pressure drop due to friction in a 5-mile segment of this pipe using a pipe not different value of this. So we have used this. So we have calculated the friction factor. So the friction factor we got from that integration is 0.0164. Let me see, let me check again. 0.0164 is okay. Now H is the same thing as FL over D times V square all over 2G. So now to calculate this, we have gotten our velocity to be 8.038 feet per second. So to calculate the H now, you have 0.0164 times the length. The pipe length is 5 miles. Divide by the D, which is a small d. Let me just a small d, which is 19.25 inches, times this, which is 8.038 feet per second, or square, divided by 2G. The G is 32.2 feet per second square. Now we now have this. So this is 0.0164 times 5 times, now 5 miles, sorry, 5 miles. Now we have 5,280 feet, equivalent to 1 mile. Now times 8.038 feet per second square. Divide by 19.25 inches times 1 feet divided by 12 inches times 2 times 32.2 feet per second square. Now we have, so the whole thing is in feet now. This one will cancel out this will cancel out this, so the whole thing is in feet. So let's look at let's see what we'll get if we use our calculator. Now let's see what we'll get. So we have 0.0164 times 5 times 5280 times 8.038 square divide by 19.25 divide by 2 divide by 332.2. Now this 12 here, since it's dividing this, it will be timesing the whole answer. So it will now be times 12. So we have let me bring down this. We now have What's the answer, sir? Okay, we now have 270.775. Let's look at the unit here. We have feet here. We have feet square. So feet square, feet cube here now. Divide by feet cube all over second square. Okay, let me just say this feet square all over, because this one will cancel out this. The mile will cancel out the mile. So you have feet cube all over second square. Divide by this one. Now we have this inches will cancel out this inches. So you have feet. You have feet square divided by second square. So this one will cancel out this. So you are left with 27.775 feet. So now the age is 27.775 feet. Now we needed to convert this in heads of the fluid. So we needed to convert this to psi. So what we'll do, in water, let's say in a fluid now, let's take this small portion of the fluid. Now we want to calculate the pressure here at this height, h. So what we'll do now, the pressure here now will not be. Now let me draw a free body diagram of that condition. We're looking at pressure here. Now there is an atmospheric pressure on the top. Then now there is a weight, the weight of the material. Now this will now be, when you sum the vertical forces, so vertical is plus equal to 0. So because it's in equilibrium, so all the forces is not in motion. So now the assuming is not in motion. Now the vertical forces is positive, so you have P minus the P, now the pressure, times this area is the force, times there is a small area there, then this atmospheric times the area give you the force, minus the weight of the fluid. Now here you have P minus P atmospheric all over M times A minus the weight. Now what is the weight? The weight, now you have the height here. So the volume of that element will now be the height times the small area under here, which is the volume. Now the density, density is equal to mass all over volume. Now that means, it implies that, okay, let me write it there. That means mass is same thing as density times volume. times volume. Now, so we have this times height times A. This is the density. Then the weight. Weight is same thing as mass times G. Now this one is mass. So the weight will now be density times A times height times A times G. Now we have P minus P atmospheric times A minus, substituting this expression here, you have this equal to 0. So I have P minus P atmospheric A equal to HAG. So if you cancel out the A cancels out. You have P minus P A atmospheric equal to this. So you have these two things. Now, density of the fluid is same thing as the specific gravity times the density of water, and the density of the fluid is so density of the fluid, density of water. Let me also give you, I'll give you the density of water in customary units. The density of water in pounds per feet cube. So that means I'll put G here. So density of water G here, this should be 62.4 pounds per feet cube. So that means the density of the fluid now will not be from here. The density of the fluid will now be specific gravity times the density of water. That is with G here. Now let me just complete it. G here. That is acceleration due to gravity. This. So now if you have this, which is density of the fluid times the specific gravity times this, which is 62.4. So now that means this and this, we have gotten it to be specific gravity times 62.4 times H. The H is in feet. Now this minus atmospheric. So this one will be gauge pressure. This should be the gauge pressure. At that height. So we have, let me complete this well. This one does not have a unit. This is 62.4 pounds per feet cube times the height, and the head is 27.775 feet. Now the specific gravity of the fluid is what? Okay, 0.85 times 62.4 times 270.775. This will now be in pounds per feet square. Now we needed to change this to pounds per inch square, which is PSI. Pound feet cube m square, sorry. So this times, I needed to remove this feet here, so I will now say 1 feet is equivalent to 12 inches, so all square. Now we will be left with this will be 0.85 times 62.4 times 270.775 divided by 12 square is 144. Let me write it well. Pounds per inch square. So now let's look at what we get from the calculator. It's okay. We'll have this times. Thank you. Times 62.4 times 0.85 divide by 144 equal to, then wait equal to, this will give us now 99.74 PSI. 99.724 PSI. So that is what we get now. So let's look at using the program I created. Let me look at it. Let me just create. Let me make okay, let's put it inside here. Okay, let's go back. Sorry, let's go back. Okay, this is that's the friction factor. Okay, this is it. What is it? Sorry, let me come. Sorry, okay. Sorry. Okay, let me just run it straight here. Straight from here. So, pressure drop calculator. So using this, we have this to be 5.9. Let me see. We have that to be 5.9. 5.9. Then what is next? The float. The flow rate is 25,000. Then the specific gravity is 0.85. 0.85. Okay. The outer pipe diameter is 20 inches. Outer pipe diameter is 20 inches. Pipe thickness is 0.375. So let's look at the second question now. The second question, the pipe length is 5 miles. It's 5 miles. And then let me use calculator now. 5 times 5280 to convert to feet. So you have this. Let me copy this. Let me copy this and paste it in. Now the pipe roughness, what did they give us? 0.002. 0.002. So this is what we get. So let's calculate. We have friction factor. This is this. So let's compare with our calculator. When we calculated. Now in previous questions we got our average velocity as 8.04. The Reynold number is 203114, but here is 203038. Okay, which also show that is a turbulence flow. Okay, now the friction factor we got is 0.0164. So from my program I have 0.01164. Okay, correct, the same. Now the pressure drop in feet is 270.78. 270. Okay, here we have 270.775, the same thing. Now for the pressure drop in PSI, I have 99.74. What did we get here? We got 99.64. Oh, the same. Now it's okay. Now let's look at the difference. Let's calculate the pressure drop using modified Colobriggs-White equation. Let me see. We have this to be 5.9, this to be 25,000, this to be 0.85. Now this is 0.002, this is 20, this is 0.375, this is, let me paste. So I have that. Let me solve. So we have this. See, so the difference is the same what we got there in the other one. Let's look at the cell. You have this as 0.0164. It's 0.0167. So the same thing. So the Reynold number is the same. The fluid velocity is slightly different. This is 275.07. This is over 100. So Yes, sir. So that is it. So let's stop here. Thank you for watching. Have a nice day. If you like this video, please subscribe to my channel. Thank you.